No. Okay, so we are doing completing the square. We're still solving quadratics. Couple things that we need to know. The form that we want it to be in when we're completing the square is ax squared plus bx equals negative c. So you have to move your c value. Yes, I say negative, but does that mean it's going to be negative no matter what?
No.
No, because it could be positive, but it's because it's the opposite of what it would have been if it was proper. Yes? Okay, and then once you write it like that, you're going to rewrite it. Okay, that's enough. Like this. So you have it blank. Well, the reason I have a blank on both sides is because to keep it equal, what I do to one side, I have to do the other, correct? So that's why I have it on both sides. So just as an example, if you're given, this is what a perfect square looks like, we know that this can also be considered a square, right? So this is a perfect square trinomial, except it's written like this, because if I were to write this twice, which is what squared means, and multiply, I would do x times x times 4 times x, 4 times 4, and I get x squared plus 8x plus 16. So because these are the two binomials, good lord, tripping over my words, the two binomials are exactly the same, we call this a perfect square trinomial. Okay, you'll notice that the first term is a perfect square, and your last term is a perfect square, but is 8 a perfect square?
No.
No, and that's okay. However, you could see x squared plus 24 plus 16. Does that mean that's also a perfect square trinomial? No. So this is the test. You take your b term, divide it by 2, and square it, and that should equal c. So what's 8 divided by 2? And what's 4 squared?
16.
Did it work?
Yeah.
That's why it's a perfect square. So if you had 24 in the middle, this would not be a perfect square trinomial. Okay? So when we know, because we just did 8 over 2, b over 2 is 4, 4 squared is 16. So this is a perfect square. When you know it's a perfect square trinomial, you can rewrite it as something squared. You don't have to worry about the b term because we know this is true. What's the square root of x squared?
X.
Whatever symbol's in the front is what goes here. So if this was x squared minus, we would put a minus. This should always be plus. And then the square root of 16 is 4. So that's what that would turn into. Okay, so knowing those things, we're going to get started on some practice problems. So if you look at number 1, it's already written how we want it. It's A, B, C's on the other side, yes? So now I'm going to rewrite it with my blanks. So x squared plus 2x plus something equals negative 4 plus something. And if I want this to be a perfect square, I'm going to pay attention to my b term. What's half of 2? 1. And what's 1 squared? 1. So we're going to add 1 to both sides to make this a perfect square trinomial. So I'm going to rewrite this as a perfect square. What's the square root of x squared?
X.
This is plus, so this is plus. And what's the square root of 1? 1. And on this side, I'm not changing anything. What's negative 4 plus 1? Negative 3. Do I know how to solve from there?
Yes.
What method can we use?
Square root.
Yeah, we can use the square root method. So now we're just going back to a method we already learned. So that's all that this method does, is it puts it in the perfect form to do the square root method. So knowing that, what's squared is already alone, so what do I do?
Cancel.
By square rooting both sides. So square root, square root, square root cancels the squared on the left, and I get x plus 1 equals. Well, on this side I did the square root of a number, so I get plus and minus. What else happens there?
Take a
I, because it's negative on the inside, so we have to put an I. And does the square root of 3 simplify? So it just stays square root of 3. Am I done? What do I need to do? subtract 1 from both sides, and I get x equals -1 plus or minus I root 3. Are these like terms?
No.
No. This one has an I, this one doesn't, this one has a root, this one doesn't. So that's as simple as this gets, but we have to separate it. So -1 minus I root 3, -1 plus I root 3. There's your answer. Any questions with that? So what I want you to realize is the only new part is this first part. Getting it in this form is the only new part. I also want you to see that whatever goes here is whatever we squared here. Oh, sorry, I highlighted the wrong spot. Not there. There. The ones really confuse me. I'll fix it on the next one. Okay, so look at number 2. So, is it set up yet? What do I need to do? Move the 1. So I'm going to add 1 to both sides. And I have m squared minus 7m leave space equals +1. If you don't leave space, it's not a big deal. You're just going to have to rewrite it again, though. So I'm going to do plus something plus something. How do I figure out what I'm adding? Half of my b. You don't have to worry about the negative, so we're just looking at the number. So we have 7 over 2. Does that simplify? No, so we're just going to square it. What's 7 squared? And what's 2 squared? 4. So I know this one looks super gross, but just wait. And then what I was saying a second ago is whatever you square is what goes in your perfect square. So what squared gives you m squared? M. This is minus, so this is minus. And what I squared is 7 over 2. So that becomes 7 over 2. So do you see what I'm saying now? What you squared is what goes here. Okay, equals, well, 1 plus 49 over 4. If you're like me, that doesn't just register in your head. So we're going to do 49 over 4 plus 1. And I get 53 over 4. Okay, so I know we have ugly fractions, but we're still following the same steps we were following before. So what do we do now? Square root both sides. So I'm going to take the square root of this side, and I'm going to take the square root of this side. So square root cancels the squared, and we're left with m minus 7 over 2 equals, well, when you have a square root and it's a fraction, you can separate. So top, bottom. And I know 53 is prime, y'all, but what's the square root of 4? And it's because you're not allowed to have a square root in the denominator. So we always have to separate and simplify if possible. And you won't turn anything into decimals today. Everything will stay in fractions. So knowing that, what's my last step?
Plus.
Yeah, add 7 over 2 to both sides. And we get m equals 7 over 2 plus or minus the square root of 53 over 2. Does that combine?
No.
No. Do either of the fractions simplify?
No.
No, so there's your answer. And you can combine the denominators into a single fraction because they're both 2's. You could also leave it separate. Either way is correct. So yes, I know that they can get a little gross sometimes with fractions, but that doesn't mean it's harder. Because in the end, was that really that much harder? No. So don't stress out about those. Okay, when you're done writing that down, I want you to look at number 3 and tell me what's different about number 3 than number 1 and number 2. There's a GCF, okay? Even if it's not a GCF, even if it doesn't go into everything perfect, anytime you have a term at the front, you have to divide it out. Okay, but because I'm going to divide every term on both sides of the equal sign, I don't have to write it as a GCF. Does that make sense? So I'm going to divide by 2, divide by 2, divide by 2, divide by 2. See how I also divided the right side of the equal sign? That's why I don't have to worry about it. It goes away. Because what I do to one side, as long as I do it to the other, we're still equal. Well, this becomes x squared minus 8x minus 9 equals 0. Now what's my next step? Now that it looks like number 1 and 2. Add the 9 to both sides. We get x squared minus 8x plus something equals 9 plus something. So knowing that, what do I do to figure out what I'm adding? Half of my b, what's 8 divided by 2? And what's 4 squared?
16.
So I'm adding 16 to both sides. And now I have to write it as something squared because that's the whole point. We made it a perfect square to be able to write it like this, right? So knowing that, what's the square root of x squared? And this is minus, so that's what goes in the middle. And what's the square root of 16? 4. And what's 9 plus 16? If you type in your calculator, you get 25. Now what do I do? Now it's set up to solve by square root method, right? So I do the square root of both sides. Square root cancels the squared, and I'm left with x minus 4 equals positive and negative what? 5. Now be careful. A lot of things I've been seeing mistake-wise is you're telling me the square root of 25 is the square root of 5. Y'all, if you took the square root's gone. If you break it apart and there's no leftovers, there's no more house. Does that make sense? Okay. So knowing that, what do I do now?
Plus 4.
Plus 4 on both sides. However, yes, these are like terms, but this is add and subtract. Can you add and subtract in one step?
No.
No. So when you rewrite this, you have to end up separating to simplify. So 4 plus 5 and 4 minus 5, because neither of them have an I. Neither of them have a radical. These are like terms, so we have to separate and simplify. What's 4 plus 5?
9.
And what's 4 minus 5? Negative 1. So my answer is negative 1 comma 9. Any questions with that? Okay, last one together, and then we're going to make fixes to the practice. So again, what do we do first? Not yet. Divide everything by 2 because I have a number in front. That cancels, and I'm left with x squared minus 10x plus 43 equals 0. Now, what do I do? Yes, we're going to move the 43. So minus 43, minus 43. We're going to rewrite it with a blank. X squared minus 10x plus something equals negative 43 plus something. And now we have to figure out what we want to do to change it. So what do I do to decide what I'm adding? Yeah, take my b term, 10 divided by 2, and what is that?
5.
And what's 5 squared?
25.
So what can I rewrite this first one as? Bless you. X minus 5 squared. Y'all are exactly right. And then we have negative 43 plus 25, which is negative 18. Okay, and now just like square root method, what do we do? Square root both sides. Square root cancels the squared, and we're left with x minus 5 equals positive and negative. We do have to take out an I because it's negative, so I'm going to put an I. And I have to break down 18 because I know that's not prime. So I have 2 and 9, and then 9 is 3 and 3. So what do I take out of what goes in the house?
3.
Yeah, it's 3i square root of 2. And what's my last step?
Plus 5.
Plus 5 on both sides. And can those combine?
No.
No. So we have 5 minus 3i square root of 2 and 5 plus 3i square root of 2. I just went straight into breaking it apart versus writing it one more time. Okay, so that's notes. Now we're going to look at the practice because I am cutting off 3 problems and changing 2 of them. My screw up benefits y'all. You're welcome. Okay, so we're going to cross off number 5 and 6. Cross off number 5 and 6. And a small fix here is these should both be the same letter. You can make them both Y's. You can make them both X's. It doesn't really matter. That wasn't my bad. Okay, so that's the front fixes. Yes? Cross off 5 and 6. Cool? Okay, look at the back. I just changed the X to a Y. I'll put it back in just a second. So we're crossing off number 9. And we're going to change number 10 and 14. This one is going to become 5x squared plus 15x minus 50 equals 0. And this one becomes 3x squared plus 24x equals negative 72.